Hey, what is up, guys? Today we're doing Leetcode problem number 1594, maximum non-negative product in a matrix. You're given a row times what? Row x cols matrix grid. Initially, you are located at the top left corner 0, 0, and in each step you can only move right or down in the matrix. Okay, so we're starting from the top left, we're moving right down all the way to the bottom right. Among all possible paths, starting from the top left corner 0, 0, and ending the bottom corner, rows -1, cols -1, columns -1. Find the path with the maximum non-negative product. The product of a path is the product of all integers in the grid cells visit along the path. Return the maximum non-negative product modulo 10 to the 9 plus 7. If the maximum product is negative, return -1. Notice that the modulo is performed after getting the maximum product. Yes. So we have this two-dimensional grid. We're starting here. We want to end up here, and we're going through. We're taking steps, and in each step we can either go right or down. That's the only possible steps we can take. And at the end we'll get to -2 over here, so we'll multiply. So -1 times -2 times -3 times -3 times -2. That's a possible path. -1 times -2 times -3 times -3 times -2. That's another possible path. We want to try to find. We're going to multiply them along the way, and we want to try to find the one that's the maximum product that's also non-negative. And if the maximum one is still negative, we'll just return -1. Because if it's not possible to get non-negative product in the path from 0, 0 to 2, 2, so return -1. Here we have an example where it is possible 1, 1, 1 to 1 to -2 to -4 to 1, and that'll give us an output of 8. So this one is pretty okay. It's not that hard. The way we're going to do this is like this. At first, you want to think of it this way. So we have either two possible approaches. We can either go down or we could go right. So we can either go down or we can go right. So maybe we can do this like recursively, some kind of a recursive call where at each step we either go down, we go right, and we keep track of the cost along the way. And by the end of this, we'll end up with a possible answer, and then we'll say that, and then we'll return it at the end. Meaning that, let's say I go from -1, and then from here I can go either -2 or -2. And so I'll recursively call like some kind of helper method where I start at this point over here and at this point over here as well, and I'll keep track of my product along the way, and at the end of it I'll end up with an answer, and every time I get to this corner I'll have a final solution, and I'll have a product of that cost of that path, and then I'll keep track of the minimum one. So for example, it'll go from here. I have two choices, so I'll go also here and here, and then from here I can go to here or here, and from here I can go either from here or here. But if you notice now, when I go from here to here and then to here as well, but I can also go from here to here and here. So both times I can end up with this at this point. And so from here to the possible solution is only going to be the one best answer, right? So if I do calculate the best answer from here to the end, to the bottom right corner, then I can save it, right? I can save that some way. And so from when I go this way, this way, this way, and then from here on, I calculate the best possible answer. And then when I come back here and I start going down this path instead, by the time I'm at here, I know the best possible cost already because I already went through it when I went this way because I saved it somewhere. And so I can just reuse that. So that was the recursively kind of memoization approach. Instead, we're going to use a DP approach, and we're going to do a double for loop instead of having like a helper method that we're going to call recursively. And the way we're going to do that is we're going to go through the array like this, right? And at each step of the way, we're going to calculate the minimum cost up to this point and the maximum. The minimum product up to this point and the maximum product up to each point. Why are we doing that? Well, first off, why is the DP approach going to work? Because let's say we did this way, and then we went here, and then we came here. Right? We went here. At this point, we already calculated the minimum and the maximum products for the point above, for the previous steps, meaning the point above, the step above, or the step whether we came this way. So from here, now what we're going to do now is we need to find the maximum cost. Let's say we were going to the end, right? We need to find the maximum cost of this, right? Or the maximum product, the maximum path that we could achieve. So let's say -2, right? We have -2 over here, right? So now we know this last answer is a negative number, right? So this is a good example. If to get the maximum product so far, then what we need to do is we need to multiply this negative number by the most minimum product behind it. By the most minimum product behind it. So let's just say we're at -2 now. The most minimum product so far behind it was, let's say -6. If we multiply that -6 by -2, it would give us 12. And that would give us the maximal product, right? Because every time you multiply a negative and a positive, the sign would flip, right? So that's something you need to keep in mind. And does this work also if it was positive? If it was positive to get the maximum product, we'd also then need to multiply it by the most maximum so far, right? So if it was negative, right? In this case, -2, then we need to multiply by the minimum of the two previous ones, which is, say in this case, minimum of previous steps, which would be 6, right? And that would give us which would be, sorry, -6. We'll just say that, for example, and that would give us 12. And if it was positive, then we need to apply the maximum of the previous steps, and that would be, let's just say, it's +6 this time, and that would also give us 12. So that's something we need to keep in mind. That's something I'll explain right here when we get to this step, which is going to be a little tricky. So the way we're going to do this now is we're going to have two DP arrays, one for the minimums and one for the maximums. And then we're going to initialize both their starting points with the first point, which is right over here with G0, 0, or -1. So the minimum so far is going to be -1, the maximum so far is going to be -1. Then we're going to go through the array. We have this double for loop to go through the array. If I is equal to j and j is equal to 0, continue, meaning we're skipping the first one. Else, what we're going to do now, skip this so far. This is going to make sense as soon as we explain this. This is just to handle the corner cases where we're at the top row or at the first column. Now what we're going to do now is the maximum of the current product that we're at currently is going to be the maximum. It's a little confusing. It's going to be the maximum of either this or this. And what is this or this? It's either going to be what we're currently at multiplied by the maximum of the previous one, or we're currently at multiplied by the minimum of the previous one. This is to handle the case where it's negative. This is to handle the case where it is positive. And same thing for here. To find the minimum is going to be the minimum of what we're currently at multiplied by the maximum of what we're at before, or the minimum of what the product of the previous steps, right? And so this is just the tricky part, figuring this out. You could also use some if conditions, check if it's negative or not, and then handle if the current number is negative or not, handle that in a certain way. If the current number is positive or not, handle that in a certain way. But the main thing to notice is that we have 4 different combinations. We have either cur is positive, we have cur, and we have the previous steps, right? So either we have cur is P or N, and the previous step is either P or N, right? And so we need to mix and match all those as much as we can. So P with P, or N with N, or P with P, and we need to have something that handles all that, and these will handle all those cases. At the end of that, we'll grab the final product, which is at this corner over here. If that is still negative, we'll return -1. If it's not, then we'll return the answer modded by the mod that they told us to mod it by. And that is the final solution. I hope you guys enjoyed. Leave a like, comment, subscribe, and let me know if you have any questions. Please leave in the comments below. I'll try my best to reply to everyone.